Okay. I'd like to introduce our next speaker. And I'm going to have to ask my next speaker a little bit help how to pronounce your name. Would you?
Wei-Wu.
Wei-Wu. So
Yes.
Dr. Wei-Wu. Thank you,
Yes,
Dr.
thank
Wei-Wu.
you.
You're up. Okay.
Wei-Wu actually is Taoism.
Oh.
It means if you actually want to achieve everything,
Yes.
you do nothing.
Whoa. I'm not going to touch that one.
Okay, how do I?
Oh, yeah.
How do I?
No, you're good.
So I can just move like this.
Yeah, I believe so. Let me
Okay.
see.
Yeah. Perfect.
Okay.
Yeah.
And you're good up there.
Yeah. So actually, I'm going to talk a lot, change my emphasis of the talk today, but the title is right. Our genome is becoming increasingly more important for understanding human biology, longevity, and healthcare. How many of you have heard about Dr. Craig Venter? Okay, so today I'm going to talk a lot about him because unfortunately a few days ago I lost my friend, partner, and my mentor to cancer. Dr. Craig Venter is actually the founder of our company, Human Longevity. And but it won't change my key point today is you better have your genome sequenced, okay? So our company, Human Longevity, was started by Dr. Craig Venter about 13 years ago. And this is actually, Craig, I know Craig since 1992, so that's 30-some years ago. So when I was doing my postdoc at Mass General, one day we was discussing a paper, and this is the original Craig Venter science paper that he actually, in 1992, he bought hundreds of DNA sequencers and was randomly sequencing cDNA library. And it's called EST sequencing. But in the scientific seminar, we were talking about the paper, all the professors at Harvard was laughing about this paper. Basically say, this is a brainless, like buy a bunch of machine, sequencing bunch of genes, and you get away with publishing a science paper out of it, And I remember later on, Craig even told me, James Watson, the godfather of double helix, even told him and said, whatever you are doing about the genome project, even a monkey know how to do it. Just buy a bunch of machine and all that. But it is the same technology, random shotgun sequencing, eventually Craig used in year 2000 to beat the government-led genome project and decode the first human genome, which is actually, by the way, is his own genome. So actually, Craig Venter's genome is actually the genome of the science paper he published in year 2000, okay? And a few years back, when I had dinner with him, and after a few nice red wine, he told me, actually, James Watson actually apologized to him already about the comment that even a monkey knows how to do what he does, okay? And this is really our founder. And I'll share with you along the way that, why it is so important we're carrying his torch forward with a company called Human Longevity. And so after 13 years, and the vision of Craig about human longevity, I once asked him, why do you call this company Human Longevity? Now, Craig always think big, okay? So he doesn't think small. So the human stands for 8 billion people, okay? Because every one of us has a genome. So you have to think big. So whatever he was trying to do is to address 8 billion people, not just himself. As a matter of fact, he probably doesn't even care about himself. And longevity means we need to use today's post-genome technology with AI, with all the phenotypic data to really help people live longer and healthier. Okay, that's really the name Human Longevity came from. And the company is 13 years old, and obviously, knowing Craig, he always liked to do everything at grand scale. So he, before I got involved, he already raised $500 million. And initially, he started his first clinic in San Diego, and he decided to give everybody a Rolls Royce. Remember, 10 years ago, to decode a human genome was still $10,000. Okay, so we charged $25,000 initially, more than 10 years ago, to give you a whole genome sequencing, a whole body MRI, a microbiome, metabolome, and all that. And so at that time, we still lose money at $25,000, okay, 10 years ago. People think actually we make money. We don't. We lost $600 million so far, okay? And this is Craig. And we obviously, later on, we had a lot of, partners, and, we actually are not trying to replace today's sick care model, because if we find an early pancreatic cancer patient, we don't have a pancreatic surgeon, on staff, but we have a great friend, the former chief of surgery at Mass General, Keith Lillimore, is actually a very good friend. And he actually operated in quite a few of our early stage pancreatic cancer patients, and they're all alive and kicking. So we actually worked with Mass General because, in my opinion, Mass General, I was trained there, but Mass General also is one of the institutions. Actually, all the physicians there actually do a lot of research. Okay, so the genome, the Craig actually raced against the US government-led genome project to decode the first human genome. And the government actually spent close to $3 billion. Okay, this is actually really a huge milestone in human biology. Now, with human race, Homo sapien has been around, for 300 million years. Okay, so, but the similar, the Homo erectus, and has been around for a while. But compared to, the entire history of dinosaurs, we're babies, okay? Dinosaurs lived almost 100 million years on Earth. We're only 300,000 years, okay? So for 300,000 years is really a blip in, the Earth's history, okay? And we never knew our genome, okay? And I still, till today, as a genome scientist, I still think we underestimate the power of our DNA and genome, okay? Because if we inherited a monkey genome, we will be a monkey. There's not much you can do. Even with all the CRISPR, you cannot edit a monkey into a human, okay? So if we are a dog genome, your maximum life expectancy is 30 years old, because the Guinness record is actually 29 years and a few months, right? So a dog genome is very difficult to live beyond 30 years of age. But we human beings miraculously live to today about average maybe 80 years of age. And genome is actually 20-some years ago, decoding a genome is extremely expensive. Okay, $3 billion. But Craig started a company called Celera. He only spent about less than $200 million to decode the genome. So he used a technology called shotgun. The government was actually allocating different chromosomes to different institutes to walk the chromosome. He basically said, why even bother? Just break the DNA into pieces and sequence them like EST sequencing or shotgun sequencing, and then use computer to assemble the DNA, and then you will still get the whole genome. And he always tell me that how much in the last 26 years we have come to today, because he bought a computer system at the time only Pentagon has, which is the compact computer. He spent about $80 million to decode, assemble the first human genome, which is his genome, okay? But that $80 million hardware today only costs about $50. Okay, this is actually how far technology, it's not just the technology of biology, it's the computational power, AI, machine learning is really moving fast. Just today, we have decided to launch a genome for all. We believe every human being should have their genome sequenced. So in honor of Craig, I already decided to launch a $5.99 genome sequencing, okay? So actually for this conference, if you guys want to do it, we'll give you a discount, okay? Go track down. Because I truly believe, with all the knowledge we have accumulated, that actually genome should be available to the entire world. And I'll share with you, and when Craig started human longevity, I'll go back to tell you a little bit of my story. So after we criticized Craig's first paper at Harvard 30-some years ago, 2 weeks later, maybe it's karma or, I got a call from a professor, Dr. Bill Hasselden. I don't know how many of you know Dr. Bill Hasselden. He said, we're starting a new company called Human Genome Sciences. This is 1992. And it was based on Craig's EST paper in Science. And they say, we want to hire you. Okay, and I would say that we just criticized the paper big time. And why do I want to join a company? Was just raised $10 million in 1992. But Bill told me, he said, you better go check it out, okay? It's in Maryland. So he bought me an airplane ticket in the end of December 1992, flew me to Maryland to see Craig's lab. And I was actually amazed, okay, because they bought 100 sequencing machine. This is 1992, okay? And it was sequencing hundreds of genes a day, okay? So I already was offered as an assistant professor at Mass General, believe it or not, when I was 26 years old. But I turned down the academic offer and decided to join Craig in January of 1993, okay? So I always blame Craig for not becoming a professor at Harvard, okay? So, so after Human Genome Sciences, we went public in 1994. We hit $2 billion market cap. During the crazy genomic bubble, we hit actually $15 billion market cap, the Human Genome Sciences. And what I learned is by building companies, it's actually the best way to bring technology to the masses. Because if you're an academic professor, your resources are limited. If you want to spend $600 million to do a project, it's almost impossible. Okay, but in the company, it's actually possible. If you're persuasive enough, you can raise enough money to do something. Okay, so Craig's vision is that we were underestimating genome, the power of our genome. But actually, 20-some years later, or till today, all the publication in 2026 is pointing towards the fact that Craig was right. Okay, so this science paper published in January, I believe, in this year, by Weizmann Institute, pointed towards the fact that human lifespan and health span is 50 to 55% controlled by your genome. Okay, historically, with the old data, people believe genome only contributes about 15 to 20%. Imagine you have an identical twin, but your twin brother died of a smallpox at 20 years of age, but you happen to live to 90. And statisticians will look at that number and say, genome must not be important because your twin brother died at 20. You live to 90. There's a 70-year difference, so gene must not be important. But in this science paper, they took out all the accidental deaths and the deaths caused by infectious disease, accidents, and all that. And with a huge cohort, it turned out to be, if you took out all these external factors of mortality, your genome actually contributes to 50 to 55% of your life expectancy. Now, Craig's father died in his 50s. So Craig always claimed that he's already outlived his father, many, many years, right? There's also another paper coming out that every one of us in this room carries 5 to 6 pathological mutations, pathogenic mutations. Every one of you. So you need to find out what are they, okay? And there's actually another paper, I'll keep talking about it. I forgot to insert a few slides in there. Based on the UK biobank data, there's a group of people at Mass General Brigham and Women just published a landmark paper to predict heart attack. Heart attack is one of the most, it's still the #1 cause of death in the United States or developed nation. They followed more than 200,000 people in the UK biobank for 12 years. So after 12 years, 6,000 heart attack event has happened. So they go back 12 years to look at what are the factors can predict the 6,000 events out of 200,000 people in 12 years. It turned out to be your genome is the most important one. Even for 50, in different age group, the predictive value is different. If you're only 40 years of age, your genome is actually 50% of the weight of the predictive algorithm. So if you're only 40 years old, you want to know your heart attack risk, you better understand your genome, because 50% of the weight comes from your actually genome. The second most predictive marker is high-sensitive CRP, inflammation. It's actually more important than LDL, okay? So, and then third is LDL, and fourth is LP(a). So if you actually look at that study just published in Nature, I believe, or JACC, is actually you again need to understand your genome, okay, in order to really predict your risk in life. Because every one of us is a bell curve. Some people are born, to live over 100. So Natalie and I are working on a supercentenarian project, because I'm actually a big believer that supercentenarian, probably their genetics is a little bit different. And I'm also sponsoring a project at Mass General. It turned out to be today they are seeing more pediatric cancer patients than ever before. So, people are, yeah. Oh, 5 minutes. Okay, I should be able to finish in 5 minutes. And bottom line is genome is becoming increasingly more important. I will look at this curve. So the revolution of longevity really just only happened in about last 100-some years, okay? We human beings wandered on Earth for 300,000 years. Our average life expectancy was about 30 years old. And longevity really is a science. But in the last 100 years, the biggest revolution is antibiotics and vaccine, because we no longer die from smallpox, pneumonia, and all these infectious diseases anymore. But today, our #1, mortality risk is cardiovascular disease, cancer, dementia, diabetes. So if you take the top 4 killers in the United States, which contributes to about 70 to 80% of the 3 million deaths every year happen in the United States. Now, there's 3 group of people. One group of people think actually people will start into the longevity curve is going to decline. And other people think, this is going to be plateau. But the other group of people like me, I think that we human beings are going to go beyond 100 plus. So we'll see in 50 years whether we'll find out where this curve goes, okay? I'm not going to talk about these anymore, but there are clearly, people who can live over 100, like, Charlie Munger, Henry Kissinger, including Jimmy Carter, but there are also a lot of famous people don't live beyond 60, right? So, we publish a lot. After spending $600 million, we were ranked by Nature as the 25th company in publishing papers. We almost beat a 400-year-old company, Bayer Pharmaceutical. But our landmark paper is this PNS paper. Basically, this PNS paper, when you use genetics, whole body MI, or the omics technology, you will find out of 1,000 people, 14% of them already have life-threatening findings. They already have a cancer, a brain aneurysm, or their blood vessel is already 80% blocked. But about 40% of us has long-term risk, like diabetes, dementia, and all that, right? So this is really the PNS paper we published. And I think it still holds true after we have more than 10,000 people. This is our, so we have different pillars. And so the first pillar is, I always say, don't die of stupid diseases. 100 years ago is don't die of smallpox, don't die of pneumonia. But today is don't die of a heart attack, don't die of a cancer. And cancer is obviously, so I'll talk a little bit about Craig, because Craig, most people don't know, he has been fighting cancer for more than almost 2 decades, okay? And because his genome is public domain, if anybody knows how to analyze polygenic risk score, all you need to do is go to NCBI and download Craig's genome, and you can analyze it. According to him, his melanoma polygenic risk score is more than 90 percentile. So he's actually very high risk. And he told me that every year he has to take out 2 to 3 lesions from his skin. About 10 years ago, we diagnosed his prostate cancer in 2016. Now, remember, he didn't start human longevity. Our clinic didn't get started until he's almost 70 years old, okay? And we found his prostate cancer. But this time, unfortunately, he has a really, really bad cancer. It's a third site, okay? But he decided, a few months ago, we were talking about, he decided to, use the most brave intervention. He was thinking about mRNA vaccine, aggressive immunotherapy. But unfortunately, he didn't die of the cancer. He died of the complication of the immunotherapy, which is actually, he had a huge infection in the lung, and, he died. Knowing Craig, he always liked to take on the difficulty head on with the, strongest power. And, so it's really sorry to hear about that. I'm going to skip most of these. So Craig is a visionary. He always tells me he has a genetic trait called phantasia. How many of you guys have heard about it? So people who has phantasia has no it's the opposite of photographic memory. So he will never survive in medical school, okay? But he always says, when he closes his eye, he can always envision what will happen in 10, 20, 30 years. Okay, so one of the things he convinced me is to embrace AI. Okay, so he actually introduced me to Jeff Hinton before Jeff Hinton got the Nobel Prize. As a matter of fact, he actually, the day Jeff Hinton came to our clinic to do his MRI is the day he got the Nobel Prize. So Jeff Hinton canceled his appointment, and Craig and I always tease, I say, this is the best cancellation excuse I have ever heard. He got a Nobel Prize. And later on, we had dinner with Jeff Hinton and celebrated that we couldn't find any cancer in him because his first wife died of ovarian cancer, his second wife died of pancreatic cancer. The reason I show this paper is it turned out to be, this is actually the last dinner I had with Craig after 30-some years. It's really sad, but we will celebrate in the future. And so AI obviously will actually revolutionize. So I'm going to stop. And we just launched our AI app. So if if people are our client, you download your app. It's like a ChatGPT, except it has your genome. I have 20 terabytes of data already with human longevity. So when I open up my app, the first question I ask is what I cannot eat. So the app told me I'm lactose intolerant. In the last 10 years with human longevity, none of my doctor ever told me I was lactose intolerant. But the app told me because I have a gene. So it just tells you that AI is going to, with all these omics technology and AI, we will bring a whole new, health to billions of people. And, just like everything we say, Craig actually always remind me that actually don't worry about other people say. He always teased, he said, scientists think he's a lousy scientist. Business people think he's a lousy businessman. Okay, he said he doesn't give a damn. Okay, so just march forward, and the future is always created by people like Craig. So remember, one of his biggest achievements, he thought he would get the Nobel Prize for that, but he never thought he would get the Nobel Prize for decoding the genome. But he's the first scientist actually made a synthetic microbiome, but the entire DNA was synthesized, using chemicals, okay, and the cell was alive. And being a very interesting, artist, human being, he actually created a code in the synthetic microbiome. So he basically used 3 genetic code, GAT, to represent a human English letter. So he coded this quote in the first synthetic microbiome: to live, to err, to fall, to triumph, to recreate life out of life. And it reminds me a quote: for our individual human being to achieve immortality, the only way to do it is to give yourself up. And as far as I'm concerned, Craig has already achieved immortality. Thank you so much.
Thank you so much. We're going to have some questions, so don't go anywhere. But I also have a Craig Venter story as well. So I was at the Genome Institute in Walnut Creek a little while ago, and in 2010 we had a conference here, well, not here, but in Walnut Creek. And Craig was there, and he announced the fact that he actually basically created a new life form, right? I mean, the DNA was all his. I mean, he put it there, he sequenced it, everything, and it worked. Now, he didn't create the actual cell, but the instructions that organism was following was all Craig's, right? All of it. And I knew he was going to be there because, I was at the JGI and I knew he was going to come. So I had a book called The Double Helix. I'm not sure if you've heard of it. It was written by, James Watson or something like that. I think that's what his name is, right? James Watson, yeah. And James signed my copy of The Double Helix. So I thought it'd be really cool if I brought my copy of The Double Helix signed by James Watson and have it signed by Craig Venter. And so I showed it to Craig and said, Craig, would you mind? And he said, sure. So I have a book with Watson's and Venter's signature on it, and it's called The Double Helix. And it's in my library at home, so it's really cool. All right, so I'm sure we have questions. Felipe. Oh, by the way, we're running about an hour... We're running about an hour late, but, I think the information here is worth it. I hope you don't mind. I mean, it's like, yeah, right. So we're okay. Here we go. And by the way, we're going to have one more speaker and then have lunch. And by the way, I've cheated. I've had lunch already because I know we're going to talk a little bit, so I want to get a little, but it's delicious. You'll love it. So hang in there. One more speaker. Okay, here we go.
All right. Of course, everything that Craig has done is fantastic, and I believe a lot can be gleaned from the genome, and you want to sequence the genome of everybody. I've never sequenced my gene. I don't know my genome. Why is that? It's not a problem with the genome. The problem is how it's interpreted. Because, as I mentioned in my talk, the focus has always been on risk factors for disease. And I gain nothing by knowing that I have a slight risk of developing a particular disease if I don't know my protective genes. There's a lot of protective genes. So knowing that I have risk factors doesn't help me unless I know I also have protective genes. If I don't have them, then I have to worry. But we don't know that. The focus is always only on risk factors, and we never look for what protects you from the diseases.
Prevention is worth an ounce of cure or something like that? How does that work, right? prevent? All right, here we go. It's a great question.
Yeah, it's a great question. So this is really, this is why Craig started human longevity. Because he believed that this project probably will last 50, 100 years because you need outcome data to actually interpret the genome. Because if you look at people like Angelina Jolie, she has a BRCA1 mutation, right? So but her family has phenotype. Her mother died of breast cancer at 58, I believe. Her mother's sister died around 61. So in her family with the same mutation, she has phenotype. So her risk, my understanding, is 85% of having breast cancer around age 60. Now, if some women carry the same mutation, but their family never have phenotype, the risk is only 15%. Okay, that means there are other genes that we probably don't even understand. With the same BRCA1 mutation, it can go from 15% to 85%. Yeah, but we need to learn. Craig's vision is, this is why he's creating a new company. Or actually, you have to give credit to institutions like UK Biobank. They already envisioned that we need longitudinal outcome data to learn our genome, right? If the most famous study is the Framingham study, it's been around for, I think, 80 years now. Actually everything we learn about today's heart attack, cardiovascular disease, a lot of them came from the Framingham study, started, I think, in 1948, right? So we human beings didn't even know hypertension was one of the major causes of cardiovascular disease without Framingham study. And even the gene like PCSK9 involved in high lipidemia was discovered from the Framingham study. So I think, because we don't know now, but we already know a lot, okay? For instance, we do study genes like a supercentenarian gene like FOXO3, right? So, luckily I have the best copy of FOXO3. So I can drink a little bit. And so my, alcohol dehydrogenase is the GG type. That means I can drink some wine, okay? Especially with friends, okay? So this, so if you know all these protective genes, you may be able to live your life a little bit more interestingly, right? So that's the, I think, this is exactly to your question is we probably will take our next 10, like for instance, this 2 months ago, this heart attack paper published, without the UK Biobank data, that algorithm can never be perfected. Now we are using our data set to improve on UK Biobank because our data is deeper than UK Biobank. We have whole body MI, annual whole body MI data. We have a lot more data. We're actually launching a proteomic panel with Tony Viscori with 3,000 proteins. So when I talked to Hinton not long ago, he basically say, in today's world of AI, don't worry about, just collect as much data as humanly possible because AI in the future will be able to tease out the noise and find the real algorithm for every one of us. Yeah. So.
All right, thank you very much. I'm going to take a sprint up there because we have a question way up in the rafters. And maybe you're going to come and join me. Let's meet halfway, okay? I'll make you a deal. All right. This is our last question for today because I have been told that we're running a bit late. I know we are. Here we go. Last question.
Hi, Wei-Wu. Just Jaspal here. I just have a question. I heard in the earlier part of your speech is that you focus on inflammation. Is that true? And if yes, to your inflammation, and if yes, then how do you detect inflammation to your patient set that you pointed out that you have helped personalized medicine for more than 10,000 patients? So around inflammation, and how do you detect to your current audience set of patients? Thank you.
All right, and you'll have to wait because we want to record this. And again, this mic does the auditorium and also does the live stream. I think I mentioned that a few times, but anyways, just here we go. Right there, yeah.
In this JCC paper, they used a marker called high-sensitive CRP. Right, that's one marker, and there's this famous professor, Paul Riddiger, actually, he approved the Crestor using high-sensitive CRP as a major measure. But now, we actually, believe it or not, I'm going to tell you a little bit pre-announcement. We are working with an amazing proteomic company called Alamar, if you haven't heard about it. They actually created a platform. It's almost like the Illumina for genome, but it's the Illumina for proteome. And it's, we are launching a inflammation panel, which has about 100 proteins, including TNF, IL-6, all the cytokines and all that. And there's an algorithm for that. It's actually going to be available for our client, probably next week. So, and it's actually pretty inexpensive, a few $100, so you can actually do it. Unfortunately, we are also doing, the Tony Viscori's a protein panel, but unfortunately, that panel is $3,000–4,000. It's a much more expensive protein panel. We save our serum from our client, so we can always go retesting their actually serums. Does that answer your question?
Yes, thank you.
Okay, yeah.
All right, thank you again, thank you. And a little bit, a lot of applause, actually. Thank you so much, thank you so much. All right, great. Okay, very good.